All right, let's go ahead and look at a couple of these guys. Let's look at this one here first. So secant is 1 over the cosine, and cosecant is 1 over the sine. So I need to figure out what the cosine of this is, so I can just flip it. So 4/3 is 1/3, 2/3, 3/3, 4/3. So right here is where we're talking about. And the cosine of this value is equal to -1. I'm sorry, -1/2. Sorry, this length here, -1/2. But when I flip it, that becomes -2 over 1. So for the sine of 210, and 210 is right here, the sine of this is equal to -1/2 as well. But when I flip that, I get -2 as well. So again, this was equal to -1/2, this is equal to -1/2, but when I flip them, they become 2 over 1. So -2 plus a -2 is simply a -4. Let's look at some of these guys down here. Let's look at one of these secant and tangent guys, and then we'll also look at the cosecant and cotangent guys. So for the secant squared, secant is 1 over the cos, and tangent is the sine over the cos. So 5/6 is right here. It's less than 6/6 because that's equal to just plain old pi. And for the cosine, it's equal to -√3 over 2, but I do need to flip it. So √3 over 2 negative, and then it does say I need to square it, so I'm going to square it. So for the tangent of the same exact spot, it is the sine, which is 1/2, and it's divided by the cosine, which is -√3 over 2. And then I need to divide this, so I need to multiply by the reciprocal. So that gives me just 1 over √3. And I need to square that. So squaring this is going to be a positive when I'm done, so that's going to be 4 on top. And √3 times √3 is √9, and the square root of 9 is 3, so that's just 3. Then I'm going to subtract 1 squared is 1, √3 times √3, same thing. So I get 4/3 minus 1/3 is equal to 3/3, which is equal to just plain old 1. Let's go ahead and look at this one here. The cosecant is 1 over the sine, and the cotangent is the cos over the sine. So these are all just defined to be that way, so you just can hopefully have those in your notes. And so sine of pi over 3, here's pi over 3 right here. So the sine of pi over 3 is √3 over 2, but I do need to flip it. And I'm going to have to square it. And the cosine of 60 degrees, so it's the same location. So the cosine of 60 degrees is equal to 1/2. And then I'm going to multiply by the reciprocal of the sine. So the sine is √3 over 2, but reciprocating that is 2 over √3. Again, why did I multiply by the reciprocal? Because I'm dividing by the sine, so I need to multiply by the flip. So I do that, I get 4 over 3, and those cancel, and oh, check it out, I get 1/3 again, which is again 3 over 3, which is again equal to 1. So looking at all of that, you find that if you had done both of them, they both would have turned out to be 1. And then both of these, if you'd done both of those, they also would have turned out to be 1. And you can go ahead and just plug those numbers in, try any different value. So you could do 180, you could do 90, you could do anything, and see if it really is true. And it works out. So that being said, it's all coming together here, is that now what we say is that let's have variations of these guys. So if I can get this by itself, that means I need to move the tangent. Oh, plus, sorry. When I move it over, it becomes positive. If I want to get tangent by itself, let's look at that. If I want to get tangent by itself, what I would want to do is move the tangent over here, which would make it a positive, and then I would want to move the 1 over there. So let's look at that again. So if I want to get tangent by itself, I'm going to move it to the other side, making it a positive, and then I'm going to subtract a 1. So I'm going to get secant squared minus 1. So then I look down here and do the same thing. I want to get this by itself, so it's just simply 1 minus cotangent. Whoops, that is not how you spell cotangent. And then this one here, same thing. I want to move this to make it positive, which means I also need to move this one over to the other side. So cosecant minus 1. So these are all now valid identities. So make sure that those are in your notes. And what we're going to do is to see if we can change this around so we can form the identities of these. So what I want to do is look at sine squared is really 1 over the cosecant squared. Is that what we want to do? Actually, let's look at A or B. So let's look at changing them into this one here. Let's do this. So first of all, what I would want to do is say, I want to get 1 all by itself. And so I want to go ahead and move. Actually, hold on a second.